Today we are going to talk about the topic on soil, water and plant relationships. We have in the last topic we have discussed on various basic aspects of irrigation water management. When we talk of irrigation water management, we must start with the understanding of soil, water and plant relationship. Because soil is a medium which is used to store the moisture, which will be in turn used by the plant. So is a relationship which is very essential to be understood if we really want to make use of the water resources available to us in a most judicious manner. First of all, we'll like to look into the various properties of the soil which are important from the point of view of the crop production. And the first in these properties is the soil composition, which has its own importance. What do we mean by the soil composition? As we know, the soil is made up of these various elements. The soil contains mineral particles. It can contain organic particles. It has the pores. It can also have living material. The mineral particles, basically they are the basic parent rock which has degraded over the time and it has disintegrated to create these particles, and that forms one of the basic constant of the soil composition. Then the soil can also contain organic particles. These organic particles are the residuals of plants or of animals at different levels of decay. And these organic particles play an important role in different manners, in the sense that the composition of the soil, if the organic particles are there, it can help in the chemical reactions, it can help in the storage of water. And then the pores is another important aspect of soil. The pores can either be filled up by water or by the air. Now these pore spaces play a very important role in terms of providing the minerals which are dissolved in the water which is available in the pore spaces, and also providing aeration to the plants. through their root system. Then the plant can also have living materials. They can be worms, they can be, even the roots are also, they can be called as living material. And these living material, again, they have an important role to play. So all these things put together, when you look at the soil and their constituents, then you try to understand the composition in terms of their storage of water, in terms of their availability of water, because ultimately this matrix, the soil matrix, is going to support the plant. So from that angle, it is very desirable that we must have a proper understanding of the soil composition. At this juncture, I think we should also understand that the soil composition is something which cannot be changed by the farmer, is something which cannot be altered by the farmer, is something which is a characteristic of the area of the land in question. To have a look at the matrix, the soil matrix, from the point of view of the composition, here we have tried to depict the soil particles, and these are the pore spaces. Now the pore spaces are having a combination of water and air. And one more thing, that the pore space, the percentage of water or air which is available in the pore space, that normally remains fixed. If the percentage of water goes up, it will be at the cost of the air. The air can be replaced by water, and there can be a situation where if the water is used by the root system, then there can be more air and the same pore space. So if one decreases, the other increases, or if the other one increases, the previous one will decrease, and the pore spaces, the level of pore spaces remains same. We'll also look at the other properties which are important from the point of view of our agricultural practices and from the point of view of storage of water. But at this juncture, it is also important to understand that this matrix of soil, the way the water and the air is available, and the way the amount of water which can be made available to the plant root system, there are some other properties which influence that aspect. The water which is available inside is available in the form of, or is being acted upon by some forces, which will very shortly will come to those properties also, which are influencing the availability of this water. There is another term which you will very often come across, which is soil profile. What do we mean by soil profile? If you look at any soil and try to dig out the soil at a particular point, maybe up to the depth of around 2 to 3 meters, you will find that in general the soil will be made up of various layers. Now these layers can also be, sometime you term them as horizons. These various layers have different characteristics. In general, you will find that typically these layers can be classified into these different layers. They can be plough layer, deep plough layer, subsoil layer, and parent rock layer, depicting that you can have a look at this figure, which shows these typical layers. The top layer, which basically supports the growth of plants, the root system of plants is normally supported by the plough layer. This is the layer where the extent of this layer can be around 30 centimeters or so, or maybe slightly more, and most of the activity, the cultivation activity, is confined to this plough layer, and this is in comparison to the lower layers. This is having more of organic matter. The deep plough layer is the one which is supporting the deep root systems of trees, and the subsoil layer is a layer which normally doesn't support any root system. Maybe some of the roots might be penetrating into the subsoil layers, but invariably this layer will be having more of moisture availability. This will be a layer which will be saturated layer, and then this follows the parent rock layer, which is having the lowest level of the soil, or the organic matter also won't be available in this layer, and that is a layer which is representing the parent rock, from where the top layers have been formulated over the period of time. So when we talk of the soil profile, is very desirable to know how the profile is, what are the characteristics of the profile, how the profile varies from the top layer to the parent rock layer, because these layers are going to influence the availability of the moisture as well as the flow of the water, which is either being made available through the natural rainfall or through the artificial irrigation. Coming to another very important soil property which influences the moisture availability or the moisture movement is the soil texture. We all know that there are mineral soil particles which formulate the soil. But these particles can be subdivided into different classes with respect to their sizes. There are many different classifications of soil which are available in literature, and in some cases even these ranges, there can be some variation in the sizes which are presented here, but in general they don't vary much. For example, the gravel is one of the mineral soil particles. If the size of that particle is more than 1 millimeter, it is coming to the class of gravel. The sand varies from 1 to 0.5 millimeter size particles. If the particle size is between 0.5 to 0.002 millimeters, then is termed as silt, and anything below 0.002 millimeters is clay. Now, when we look at the soil will be having these proportions of the different soil particles, and the proportion can vary. Now, with the variation of those proportions, the characteristics of the soil in terms of the moisture availability and the moisture flow, they are going to be influenced. So it is important to know those characteristics, and it is important to know those classifications which have been put forward in literature, and we can later on use those properties in terms of knowing our soils better. So with that intention, the soil texture is having its own importance, and let me give you at least the one textural classification which is given by US Department of Agriculture. Now, with respect to their classification, clays up to 0.002, anything less than 0.002 millimeters is termed as clay. The silt is 0.05 and less, or between 0.002 and 0.05, and the gravel, as I have just mentioned, is anything greater than 2.0 millimeters. Now, as far as the sand is concerned, is subclassified into 5 different varieties. Very fine sand, medium sand, coarse sand, and very coarse sand. and their sizes vary. In this manner. So this is one typical textural classification. However, another classification, if I extend the same thing, Atterberg gave another classification which had the same size as far as clay is concerned. It had the same size as far as gravel is concerned, but gave a different size for silt. Silt, as per his classification, was only between 0.002 to 0.02, and the sand he only subdivided into two subcomponents, fine sand and coarse sand. And the demarcation between fine sand and coarse sand was the size of 0.2 millimeters. Now this is more simple a classification. And there are many more complicated classifications. Later on, the US Department of Agriculture came out with a more you can say a much more diversified classification, which had the soil classes divided into 12 different subgroups. Now it is a function of how refined your study is going to be, what are the various parameters which you are going to consider, how much variation of various properties you are going to expect, and what is their importance. You can go in for a very complicated classification provided you have sufficient data. But in general, most of the time you will find that broad classifications which are just sufficient to give you reasonably good information on the changing of or the change of basic properties of soil from the point of view of their absorption of soil moisture and the release of the soil moisture, or the way they let the soil let the moisture flow out of their structure. That is what is going to be important. So from that angle, even if you know the classifications or you consider them in the most general manner, which are reasonably sufficient to take care of your interests, these three textural classifications are quite sufficient, and these are coarse textured soils, medium textured soils and fine textured soil. Now these soils from these three classifications, there are different names given. The coarse textured soils are the ones which are predominantly having more sand components, so they are sand predominant soils. They are also sometimes termed as sandy or light soils. The medium textured soils are more silt predominant, and they can be also termed as the loamy or medium soils, and fine textured soils are clay predominant, and they are also termed as clay or heavy soils. In general, at this juncture we can, in general, say that some of the properties from the angle of our agricultural activities, the coarse texture soils are the ones which let the water move through them at a very fast rate. In comparison to the fine textured soils, where the rate of movement will be very slow. If you just try to look at a typical situation where you have two soils, let me say that this is loamy soil, and as sandy loam, to be precise. In comparison, we have another soil which is again a loamy soil but is clay loam, now if you try to make the water available at top, the way the water will move, I will have a movement of water in the sandy loam in a manner which is much faster. Let me say this is 15 minutes, this is after 40 minutes, maybe this is after 1 hour, and in comparison, in the clay loam soil, you will have a spread which is much slower in the downward direction. Maybe this will, for the soil to reach, for the water to reach this place, it might take around 4 hours, and for the water to penetrate up to this depth, it might take much more time, up to maybe up to around 24 hours. So that is the level of difference between the two. Though the spread will be much better in the case of clay soil, which is having clay predominance, in comparison to the sandy loam, but the sandy loam will have more movement and the vertical direction. Then soil structure is another aspect of soil which gives us more insight into the another property of soil, which deals with the movement of moisture through the soil. But first of all, it is important to know what do we mean by soil structure. The soil structure refers to the arrangement of soil particles. We have talked about the different soil particles, how those soil particles are arranged and they make a compound of the soil. That is what is known as the soil structures. So if you look at a group of soil particles, you can call it a soil aggregate, and the soil will be composed of many of such aggregates, and these aggregates, their position in the soil, how they are structured, how they are placed, that is what is going to decide the soil structure. Okay. Now the soil structure is something which can be altered. Earlier we had said that the soil constants, they cannot be altered, whereas the soil structure, because soil structure is something which is the structuring of the soil, which is the placement of the soil particles or the aggregates, and that can be altered through the farming activities. So the farmer can afford to alter the structures of the soil, and he can try to get that structure which is more beneficial for his agricultural activities. What are the various arrangements? What are the various arrangements of aggregates which are normally found in the soils? These are granular structure, the blocky structure, or the blocky arrangement of aggregates, prismatic, and massive. These arrangements, they influence the movement of the moisture. For example, in the case of granular structure, you will find that the moisture will be moving at a very rapid rate. On the contrary, if the structure is massive, then the rate will be very slow. Now, between the two structures, in one case, the placement of the particles will be such, the placement of the aggregates will be such that they are more pore spaces. The pore spaces are allowing the water to move through their spaces, whereas in the case of a massive structure, the placement is such that the pores are not in a position to let the moisture move out of its structure. whereas the other two structures, the blocky and the prismatic, they have a moderate rate of flow through them, and this also, the structure from this angle, it makes a lot of difference in terms of the movement of the moisture, and even the other agricultural activities. For example, if the structure is such that it has the pore spaces connected to the moisture available in the soil at some lower depths, that can enhance the evaporation activity from the soil. So to break those capillaries, to break those connecting pores, you can you can alter the structure, you can do some tilling operations, and that can reduce the loss of moisture through the evaporation. So if one has the understanding, if the farmer knows about what are the various properties and how they are active in their, how they are influencing the different processes of the moisture storage or moisture movement, then he can take the appropriate steps to ensure that those actions can be taken which are more beneficial, which are more judicious from the water management point of view. Next we'll talk in terms of infiltration. First of all, what do we understand by the infiltration process? The infiltration is the process of the water entering into the soil. So it's the process of the moisture entry into the soil and its subsequent movement into the soil of this water which has entered into the soil is known as percolation. That is how these two processes are different from each other. But infiltration process is more important because if we understand this process in a proper perspective, we can ensure a proper storage of moisture into the soil, because if the water cannot enter the soil, it cannot be stored into the soil. There might be a situation where you have applied the water onto the surface of the field and most of it has run off the field. It has not been able to penetrate into the soil, and that is where the infiltration process is having its importance. We must understand what are the various factors which govern this process of infiltration or which influence this process of infiltration. The infiltration rate before I go further, I think I must try to tell you that infiltration can be expressed in many ways. It can be expressed in terms of rate, in which case its units are depth per unit time, okay, or it can be just expressed in the form of depth, in which case is the cumulative depth, and that again has it is with respect to a time that over that depth over how much time. So in that case you are not looking at the variation of this infiltration in time, you are only interested in the final outcome, which is only the cumulative depth, that over the last so many hours how much of the depth you could accumulate into the soil. That is what will be the infiltration depth. When you talk of infiltration rate, the rate is something which is dependent on many factors, and the major factors which influence the infiltration rate are soil texture, soil moisture content, and soil structure. I think we'll stop here. Hello.